All right, hello, my gems. Today we're going to talk about 10.3 to 10.4, or sorry, 10.6, our notes about circles. And so what I'm going to do is I'm going to do this probably in two different videos. I'll do one video for 10.3 and 10.4, and then a second video for 10.5 and 10.6. Personally, what I would do if I were you is after I do like the 10.3, this section, I would pause the video and then go do the 10.3 IXLs and then do the same for each one. That way you'd like take the notes, do the practice, take the notes, do the practice. So you're not getting all of the equations kind of confused with one another. So let's get ourselves started. So 10.3 is all about arc and angle measures formed by intersecting chords, secants, and tangents. So if two secants or chords intersect inside of a circle, then the measure of the angle formed is equal to half the sum of the measures of the intercepted arcs. So what that means is this. If I were to take a look at this angle 1 right here, okay, so here's angle 1 at the center. Angle 1 opens up to the intercepted arc AD. Now, right across from angle 1 is another angle right here, and these are vertical angles, which means that these two angles in pink are congruent. The angle that this, or the arc that this angle opens up to, is arc BC. So if I want to find the measure of angle 1, all I'm going to do is I'm going to take arc AD plus arc BC. I'm going to divide it by 2. So essentially, I'm finding the average of the two arcs. So arc AD plus arc BC, and then I divide by 2. And that will give me the measure of angle 1. Same thing will work if I want to find the measure of angle 2. So angle 2 at the top opens up to AB. Its vertical angle right underneath opens up to DC. So to find the measure of the angle, I take arc AB plus arc DC, and I divide that by 2. And that will give me my measure of angle 2. So let's try an example. So in this first example, you're trying to find the measure of angle STR. So STR is this angle right here, STR. So the arc that angle opens up to is 112 degrees. Its vertical angle on the opposite side opens up to 186 degrees. So to find the measure of the angle, I take my two arcs, I add them together, and I divide by 2. So my first arc is 186, plus my second arc is 112 degrees, and then I divide that by 2. So if I add 186 and 112, I get 298. And if I divide that by 2, I get that the measure of angle STR is 149 degrees. And we're talking about an angle measure, so we do have to put a degree symbol. So this measure is 149 degrees. Okay, number 2. The measure of arc LK. So I am looking for this arc measure right here. The angle that opens up to the arc is 62 degrees. Its vertical angle opens up to arc 74 degrees. So again, I'm using the same equation, which is that the angle equals the arc plus the arc divided by 2. So my angle measure is given to me this time, it's 62, equals, I add together my two arc measures, which are the outer edges, right, of the circle. So one of my arcs is 74. The other one I don't know, which is LK. So if you want, we can just put an X there. That's what I'm trying to solve for. So I don't know what that piece is. And then I divide by 2. Now you can do some guess and check if you want, or this is just an algebra problem. To get rid of the divided by 2, I take this whole equation and I multiply by 2, because what that's going to do is that's going to cancel my 2's over here on the right side. If I multiply 2 times 62, I get 124. And I'm left with just the top, which is 74 plus x. And then to get x by itself, I subtract 74 from both sides. And I end up getting 50 degrees. So the measure of arc LK is 50 degrees. So if I wanted to double check, I could do 50 plus 74 divided by 2, and I should get 62 degrees. So those are intersections that happen inside of the circle. So you notice that where my two lines cross happens inside the circle. The next one is called on the circle intersections. Now, if a secant and a tangent intersect at a point of tangency, then the measure of each angle formed is equal to half the measure of its intercepted arc. So what that means is this: if I want to know what the is, I take that angle and I see which arc it opens up to, and it opens up to arc BA. So to find the measure of angle 1, all I'm going to do is I'm going to take the arc, the intercepted arc BA, and I'm going to take half of it. So I'll divide by 2. Same thing for if I want to find the measure of angle 2. The arc that it opens up to is this major arc over here, BCA. So to find the measure of angle 2, I will take arc BCA and divide it by 2. So you're just taking half of the arc measure. So in the first one, it says find the measure of angle DBC. So DBC is this angle right here, and it opens up to this arc DB. Now I've got a little bit of a problem, which is I have nothing on that side. The only thing I have is that this arc is worth 192 degrees. So what I'm going to do first is I'm going to figure out the remaining arc over here, DB. I know this is a circle, so a circle in total is 360 degrees. So to find just this green arc from D to B, I'm going to take 192 away from 360. So I'll take 360 minus 192. Okay, when I do that, I get 168 degrees. So that means D to B, arc DB, is worth 168 degrees. Now, to get the measure of angle B in the center here, I'm going to take 168 and I'm going to take half of it. So to find angle B, I will take 168 and I'll divide it by 2. So I end up getting that the measure of angle DBC is 84 degrees. So this little angle is 84 degrees. Next one asks you to find the measure of arc XY. So again, I'm given some pieces. I'm not given what I need. XY is this arc over here. So I need to figure out what that arc is. But I know this time that the 151 doesn't correspond with the arc measure. It actually corresponds to this angle right here. This is a 151 degrees. Now, I can figure out angle X, not arc, but the angle, because these two put together make a straight line, which is 180. So to figure out angle VXY, I'm going to take 180 and I'm going to subtract the 151. And I end up getting 29 degrees. So the angle right here is worth 29 degrees. Now, to get the arc measure, since I know the angle, instead of dividing by 2, right, I'm going to multiply by 2, because the equation is, right, you take the angle and it is the arc divided by 2. So since I know the angle is 29, I'm trying to figure out my arc, divide by 2. To get rid of that, I multiply by 2. So the measure of arc XY is 58 degrees. So this arc right here is 58. You also could have doubled the 151, gotten the rest of this, like the edge of the circle here, the arc, and then just subtracted from 360. So there's a lot of different ways you could have done this problem. The last ones are exterior intersections. So exterior intersections say if secants and tangents intersect on the exterior or outside of the circle, then the measure of the angle formed is equal to half the difference of the intercepted arc. So half means I'm going to divide by 2. Difference means I'm going to subtract. So the equation for this problem, I'm going to come do it over here, is to find the exterior angle, or I can spell. I'm going to take the big arc, the big intercepted arc, and I'm going to subtract the small intercepted arc, and then I'm going to divide by 2. So in this first picture here with 2 secants, if I want to find the measure of angle A, which is my exterior angle, I'm going to take the big arc that it intercepts. So this opens up here to the big arc is CE. And I'm going to subtract the small arc, which is BD. And then I'll divide that by 2. So I'll take CE minus BD and divide by 2. So big minus small divided by 2. The same equation for all of these problems. In the next one, my big arc is BD. And I'll subtract my small arc, which is BC. And then again, divide by 2. So it's always big minus small divided by 2. Last one, my big arc is a major arc, BDC. I use 3 letters because it is a major arc. It's bigger than 180. Minus my small arc is BC. And then divided by 2. So I'm going to use that equation for all of these problems. So in this first example here, my big arc is going to be AD, my big arc. My small arc is going to be right here, the A to C, that's my small arc. And I'm trying to find the measure of angle B, which is my exterior angle. Now, my only issue right now is I don't have the measure of this big arc. So it's really hard for me to do the problem if I don't know that. However, I do know that this arc here is 62 and this arc here is 88. And I know the whole thing is 360 degrees. So to find what's left over, to find this big arc, arc AD, I'm going to take 360 and I'm going to subtract the 62 and the 88. So when I do that, I get 210 degrees. So the big arc is worth 210 degrees. And then now I can plug it into the equation. So the exterior angle, which I don't know, equals big arc, which is 210, minus the small arc, which is 62, and then divided by 2. So I should probably grab a calculator. Big minus small divided by 2. You end up getting 74 degrees. So this angle right here, angle B, is worth 74 degrees. Okay, last one. Again, it's big minus small divided by 2. So my big arc is 191. My small arc is FH, but I don't know that one. And then I know my exterior angle is 77 degrees. So this time I'm trying to find this small arc right here. So I'm going to put an X there. So my equation is the exterior angle equals big minus small over 2. And this just becomes an algebra problem like we've done before. To get rid of the divided by 2, I'm going to multiply both sides by 2. I get 154 equals 191 minus X. To get X by itself, I subtract the 191 from both sides. I get negative 37 equals negative X, and then divide both sides by a -1 to get rid of that negative sign. I get X equals 37 degrees. So this arc right here from F to H is 37 degrees. However, the problem asks me to find the measure of arc EF. So that is this arc over here. Now, to find that arc, I know the whole thing is worth 360, so I'm going to subtract the big and the small piece from 360, and that'll give me what is left over. So I'm going to do 360 minus 191 and 37. And when I do that, I get that the measure of arc EF equals 132 degrees. So it's like multiple steps, right? Because you have to solve for the problem, but then you also have to take that answer and kind of plug it in and use it to finish up the problem. Whew. Okay. Flip it over. So on the back is section 10.4, which is all about segment lengths this time. And this one goes with IXLU.17. So the front side that we just did was talking about angle measures, right? So we're talking about like if you were to measure these with a protractor, right? We're talking about degree measures. On the back side, we're now looking at the same type of intersections, but we're talking about the lengths of them. That means the distance between the points. And so you can almost think of this like if you were to measure with a ruler, right? So how far along something is. Now, we're not going to do all the problems. I'm just going to kind of set them up because they're mostly algebra and you guys can do algebra on your own. So I'm just really going to set up the equations with you. I'll give you the final answers, and then you can actually attempt the problems yourself to see if you get the same equations, okay? So type 1 are intersecting chords inside the circle. So that means lines that cross inside of the circle. So you have two segments here. Segment AB and segment CD. All you have to do is take the two pieces of one segment, multiply them together, and set them equal to the other two segments multiplied together. So in our case, it would be AB times CD. In number 2, you've got intersecting secants outside the circle. So it almost kind of looks like a party hat here. And the equation for this one is outside times the whole. So what that means is this. When you take your first segment, right, here's segment AB, the number on the outside would be the A value. So you'd take A and then you'd multiply it times this full length. And this full length is these two pieces added together. So A plus B. You then set that equal to the opposite side, again, outside times the whole. So the outside is C, and the whole thing is C plus D. Okay, so outside times the whole is this equation. So this is the outside, and this is the whole. So you're going to laugh, but I remember this is like when you're at a party, you get excited, you go, ow, ow. So the equation for this one is ow, ow. Outside times the whole, outside times the whole. Looks like a party hat. That's how you remember it. Last one is an intersecting secant and tangent outside the line. So one goes through and one just touches the edge of the circle. The one that's by itself, the tangent line, you're going to take that piece and you're going to multiply it times itself. So A squared. And then you're going to set it equal to the other one is going to be, again, outside times the whole. So B times the whole thing would be B plus C. So like I said, I'm just going to set up the equations with you, and then you can try the rest of them on your own. So type 1, you're finding the length of BD. So first thing I do is I just identify, right, my different segments here. And because this is type 1, we take the two pieces on the same segment, we multiply them together, and then set them equal to the other two pieces of the segment. So my pink piece is 6 times 6. And I set that equal to 4 times 5x minus 1. And obviously this is like some distribution. This is just a regular algebra problem. So I'm just going to go like this. Your x value that you get is worth 2. And then to find the length of BD, so BD is the part in the green here. If I want to find that full length, I need to take my answer and plug it in. So 5 times 2 minus 1. So this is 10 minus 1. This piece right here is worth 9. And in total, the entire length of BD is worth 4 and 9 together. So I have to add them. So the full length of BD is worth 13. So definitely make sure, like on your Excels, you definitely plug in your answers. The second type 1, again, same idea. And so I'm kind of rushing, sorry, because I'm down like 5 minutes before the bell rings here. So I take the two pieces in pink, multiply them together. So 18 times 2x minus 5 equals, and then I do the two pieces in green, 14 times 2x plus 1. I always suggest put the number by itself first and then put the one that's like the expression, because you're going to have to distribute to both both of those problems. So the answer to this one is x equals 13. Again, I would definitely suggest going through and trying these problems, making sure you understand how to do them. All right, type 2. So this is the party hat. So this is the ow ow. Outside times the whole, outside times the whole. So if I look here at my pink piece, the outside number is 9 times the whole thing is 9 plus x equals, and then I do the same on the right. The outside number is 8 times the whole thing is 8 plus 19. So again, it's distribution again. And so you can distribute over here on this side, right? 9 times 9 is 81, 9 times x is 9x. On the right, you can distribute, or if you want, because these are just numbers over here, you can just add these together and then multiply it, right? So 8 plus 19 is 27. So you can just multiply 8 times 27, or if you really want to, you can distribute and do that. You'll still get the same answer. So for this one, we get x equals 15. So it's all kind of dependent on how you want to do it. Makes most sense for you. Last number 2, again, party hat is ow ow. So it's outside times the whole is outside times the whole. So for the green piece, we've got 8s on the outside times parentheses. Now it's the full length. So it's this piece here plus this piece here. So it's 8 plus 3x plus 4 equals. Same thing for the pink. Outside is 7. Whole thing is 7 plus 5x plus 2. Okay, so don't forget to add that number when you're doing the whole length. Most people forget it, and that's when they get the problem wrong. So personally, what I would do if you were doing this problem algebraically is I would combine like terms inside the parentheses, and then I would distribute. So like you can put together the 8 and the 4 and get 12. And then now this looks a little nicer, and now you can just distribute normally. Same with the right side. So I would put together the 7 and the 2 to get 9, and then put plus 5x. And then again, you can distribute and kind of solve that way. So you end up getting x equals 3. All right, last 2. So this is the one with the tangent, the number that's by itself gets multiplied by itself. And then the other piece is outside times the whole. So the green piece here would be 16 squared, or 16 times 16. So one by itself equals pink piece is outside times the whole. So outside is the 8. The whole thing is 8 plus 5x minus 1. And again, I would suggest like combining like terms. Hopefully you know how to put 16 squared into your calculator. That just means 16 times 16, which is 256. And then again, I would combine like terms here to get 8 times, you can put an 8 and a negative 1 together, and that'll give you 7 plus 5x. And then again, you go through, you do your algebra, blah, blah, blah. Get x equals 5. Okay, last one. The one that is all by itself is the tangent. That's the 24. The piece that you're going to do the outside times whole with is this pink one. So the one that's alone gets multiplied times itself, 24 squared equals. And then for this piece, this is outside times the whole. So outside is 18 times the whole thing is 18 plus x. I don't have the answer to that one, sorry. So you have to do that one on your own, or look at my answer key, which I have provided for you on Canvas. So at this point, this is the end of this video. This is just section 10.3 and 10.4. So like I said, I personally would go back now, double check your work with mine. I've put the key on Canvas already for you. But I would go back now and do the IXL for this section, the segment lengths, and then do the IXL for this section, arc measures, which is U16. Get both of those done first. And then when you're finished with them, Then I would go back through and do the notes for 10.5 and 10.6, which will be, like I said, a separate video, which I will put up for you later today. So hopefully this was helpful for you. I know that the notes are really small. I do apologize about that. But like I said, my answer key is on Canvas for you. And now you are going to iExcel, and you're going to complete those, and then you're going to go complete your Canvas quiz when you are finished with all 4 iExcels. So, or 5 iExcels, I think at this point, sorry. So, okay, if you need anything, come down to my room during lunch, and I will be more than happy to assist you. Okay, have a wonderful day. Adios.